Hello everyone and welcome to this new video tutorial. We're going to see right now optical flow. So optical flow is the vector which describes the movement of the object between two consecutive frames. Let's make it more simple. I have this object, the toothbrush, right? Let's say that I select this point that I want to track. Now I will move the object this way, so the optical flow will be this vector that detects that the object moved from here to here. How can we do that? For that we have an algorithm called Lucas-Kanade, which works this way. We have this object, detects the features of the object. Then when we move the object, it looks in the area around where the object was before. So before the object was here, it looks around and it finds that it moved in the new position. And then it selects the new point. Then again, we move the object, new position, it looks around in the area, it finds the new position, and so on. There are a few conditions, of course. The object must move really close. So as we work on with 30 frames per second, even if I do fast movement like this, the algorithm will work properly, because in each frame, now I'm going fast, but in each frame you will see going this way, the object. Now let's go to the practice and let's see it step by step. We import CV2, import numpy as np. We load the camera cv2.video capture 0. The while loop while true underscore frame is equals to cap.read, and then we show the frame cv2.im show frame and frame, and then a key event to stop the loop when we want to stop it, cv2.wait key 1. If key is equals to 27, which is the S key on the keyboard, we break the loop. Finally, we release the camera cap.release and cv2.destroy all windows. Now I'm going to run it to see if it's correct, and it is. Now we want first to be able to select a point. So I take the brush, and with the mouse I want to select this point to track. So we need to create a callback mouse function. Let's create it here. Mouse function def equals to select point. Then we need to pass few parameters. First one is mouse event, so event x, y, flags and params. If the event is equals to cv2.mouse, so that's not mouse, event L button down, so it means if we press with the left key of the mouse, then we want to get the point, so we will have point, and the position will be x and y. Another thing that we want to make, as you see, it says local variable point value is not used. So we need to make this global so that it can be used later on the while loop. So here we just say global point. Also I want to add a switch button, so that means that when we detect the point, then only then we can start to track the optical flow of such point. Before, there is no point to do that. So I can say, for example, point selected is equals to false. Then we have point, and let's make it empty, because we will fill it later on when we click. And something else, not for the moment. Actually, yes, here we can say point selected is equals to true. So here, if point selected is true, then we can draw the circle where is the point. CV2.circle on the frame, the position will be point, and next one should be radius, let's say 5. The color, let's make it red, so it's BGR format, blue 0, 0 green, and 255 of red. And let's say thickness 2. Also, I forgot to make global point selected, so also point selected is global. And let's see, let's say that I want to select the toothbrush. I click and nothing happens because I forgot something. I forgot to say to run this function on the window, so we need to do this. We need first to create the window, cv2.nameIt window frame, and make sure that this name is the same of this one. So we first create the window, then we're going to use the same window. Name window frame, and then cv2.set mouse call back to this frame window. We want to run this function select point, and I copy this one here, and now it should be all fine. So I have the toothbrush, I click, and now it's perfect. Now I click, and as you see, nothing happens. But what I want to do is, when I click, I want that the circle follows the movement of the toothbrush. Let's do that. So if point selected is equals to true, we have the point. Now we need to use the function calc optical flow Lucas-Kanade. So the function is going to return us the new points. So let's call new points. Let's call it just new points. Then status and error, because sometimes can happen that we get an error if the function can't find new points. Equals to cv2.calc optical flow pyramid L Lucas-Kanade, and later on I will explain a little bit more how this works. So as we said, the Lucas-Kanade function works with two frames, two consecutive frames. So the old one, which is old, let's call it old gray, and then the new one, which is gray frame. Old points, okay, old points. The mask, we don't have any mask, so we put none, and then the parameters of the algorithm params. So LK params, this asterisk LK params, and we're going to pass a dictionary. So let's first fix these few errors. So we have old gray, gray frame. These are all errors because we have not declared them before. We need to work with grayscale frame. So we have gray frame is equals to cv2.cvt color frame, and we convert cv2 color underscore bgr to gray. So the new frame is okay, and we need an old frame to start with. So we can create the old frame just at the beginning of our code. So let's make it here. Let's create old frame underscore frame is equals to cap.read, and old gray is equals to cv2.cvt color frame cv2.color underscore bgr to gray. Also the old gray is okay. Almost okay, because after we detect the new points, we need to say that the old gray is equals to gray frame.copy. How can I explain this? So we're working with old frame. Let's make it okay, we're working with old frame here, and then with the new frame. When we process the new frame, so we detect the new points, then the new frame gets becomes the old frame, and we start again the loop, and we detect the new frame, and so on. So of course, like when you compare two frames at each time, for each loop, the one that was new one before will be old the second loop. And so this is okay. We need to define the old points, which in this case are going to be the first point that we detect. So old points, it will be np.array, and for the moment empty. Also make sure that the points, we're going to make it not just a simple array of points, but numpy array, because numpy, why numpy? Because numpy is faster. That's why most of the time we're going to use numpy with OpenCV. All points, we define them with numpy of array. Here is empty, and we define the first time the old points when we select them with the mouse. So old points is equals to np.array, and once remember array of array x and y, and remember also the data type is equals to np.float32. It is really important that you put it this way. One more thing now. We need to define the parameters of the function Lucas-Kanade. So let's define them here somewhere at the beginning. Lucas-Kanade params, lk params is equals to a dictionary And the first thing, we have window size, so win size is equals to, let's say, 10 by 10, and I will explain all this later on. Max level is equals to 2, and criteria is equals to, open parenthesis, cv2.term criteria APS, cv2.term criteria count 10 and 0.03. We had something like this on the min shift algorithm, if you remember. Now that we have the params, let's just run it to see if everything is correct, or if we have some error. It looks like everything is correct because it's running. And of course the point doesn't move yet because we're not drawing the new points, but it's already detecting them. So for example, actually let's try it. Let's print new points. Actually I don't see much movement. Yeah, okay. So this is these are the new points that we're going to draw. So it will be new points, actually x and y. It will be new points dot ravel. So I am with this function dot ravel, I am extracting this inside, and I'm getting the position x, y of the new point. And also we need to remember that after we get the new points, like for the frame, the old points, actually the new points now becomes the new points on the next frame. So we're going to change to copy them now, is equals to new points. And let's draw them. cv2.circle frame x and y. The radius 5, the color, let's make it green, so BGR 0 blue, 255 of green and 0 of red, and -1 to means let's fill the circle. And this should be enough. I select the point and you see how great. It's not so solid, it's losing the points. Okay, it's not as solid as expected, as it's losing the point. So we can do some improvement for sure in this function, in this code. For example, one thing that we need to know is that the window size. So let's check these values. So we have window size 10 by 10. So it's checking an area of 10 pixel by 10 pixel close to the last point. So for example, we could increase this area to find bigger movement. Not bigger movement, okay. Let's say 15 by 15. Let's take again this one, and I don't know why it's not getting that exactly okay. Still not really good. It's probably okay if we move it really slow. And here there is something that we can do when we have some faster movement. As you see, when we move it fast, it goes away because it goes too far from this window size. So for this, Lucas-Kanade has implemented the pyramid function. We have seen pyramid in some previous videos, so I suggest you that you go to check that video. And now I'm going to show you an example what is going to be the difference. Let's, for example, show a pyramid of the frame. cv2.im show first level pyramid. First level, it will be equals to frame dot peer down. I don't know if I can make it this way. No, that's really suck what I did. So first level pyramid, let's make it here just before in show. First level is equals to cv2.peer down of the frame. So this one, and I need to stop the code. Okay, let's run it now. Okay, now we have two windows. First one, the big one, and the small one. The small one is a pyramid, so it's half of the first one. And as you see in the pyramid, the fast movement are easier to detect in the smaller image because it moves, while in the big window it moves of much more pixels. In the small one it moves like the same movement, looks much shorter. And so we can make this of many levels. So we have first level, let's make second level, which is second level is cv2.peer down of the first level, so it's half of the first level. I forgot to show it. Of second level, let's show the second level. Where is the, okay, here is the window, and you can see same movement in this really small. Fast movement will be easier to be detected. And so in this parameters dictionary with max level, we can define the levels of the pyramid. So let's say up to 4th level, so it will be a really small image and it will be easier to detect faster movements. And let's try it. I don't need to show this first, second level, it was just for you to understand how it works. We don't need to do that. And let's try this now. And still not perfect, but much more solid than before. Let's maybe take some bigger part. Okay, you can see how well it keeps the movement. And of course you can take many different points and track all them at the same time. It's usually better to do that. I just did it this way to make it much more simple. So we're going to see more advanced things in some of the next videos. And this is all for the moment, and thanks for watching.